Good afternoon, everyone. This is Mr. Taylor with Young Engineers of Today. Hope everyone had a wonderful weekend and their Monday is going great. And they're staying warm. Hopefully, you had a nice weekend with the great, wonderful warm weather. And now that we're transitioning back into cold weather. All right, let's get started. If you can hear me, raise your hand. All right, I see George, Alex, John Mark, Catherine, Keller, Drew, Elizabeth. Excellent. Marissa, Anthony. All right, wonderful, wonderful. I'm going to put your hands down. All right, if you can see my screen, raise your hand. All right, Anthony, George, John Mark, Catherine, Keller, Drew, Elizabeth. Excellent. I think that's everyone, Alex. All right, great. All right, tonight um, we are going over the history of computing. Uh, Thank you for asking, Marissa. Now I'm a little congested with allergies. That's all. But thank you for asking. Very nice of you. All right, we're going to be doing physical computing. Excuse me, not physical computing, history of computing. So we're going to be looking at the history of computers because we are moving into using the Raspberry Pi. Uh, so this is the way we're going to start off, give you some background history and knowledge of where we've come from, some tidbits of information to show you how we've got to the Raspberry Pi. I know that Mr. Dubik has been distributing the Raspberry Pis, excuse me, to everyone, as well as getting those out to people. And don't worry if you don't have yours yet; it's a process. I know. I think in Raleigh, people got theirs, and people in Charlotte are getting theirs right now through the week, if not by. All right. Um, and then we'll be moving into using the Raspberry Pis. Okay, so let's get started. First off, I want to start with a question. What all do you know about the history of computers? Would anyone like to raise their hand and share anything? All right, Marissa, thank you. Go ahead, Marissa.
Um, oh gosh, I can't remember the date when the first computer was made. Do you know? Because I can't remember. I had it and then I just don't remember.
You talking about like a mainframe or the ones for the government, like during World War II, that processed
Like the
information?
first ever computer. It doesn't matter what it was used for.
I don't know off the top of my head the exact date, and we're gonna be
Yeah,
looking
me
today.
neither.
Okay, well, thank you, Marissa. Let's go with Alex. Go ahead, Alex. Alex, you're unmuted.
Oopsie.
Yeah, Alex, just speak up.
I didn't mean to.
Oh, okay. Okay, let's move forward. Now, computers play a very large role in our day-to-day lives. We interact with them directly, indirectly, constantly. So let's actually see how we've gotten to this point. All right, here are just some funny lines about computers. My software never has bugs; it just develops random features. Uh, if you don't want to be replaced by a computer, don't act like one. There are 10 types of people in the world: those who understand binary and those who don't. Uh, that joke will make sense in the future. Supercomputer, what it sounded like before you bought it. To err is human. To really file up requires the root password. All right. Now, first person we're going to look at is Charles Babbage. It's considered the father of computers. From the 1820s, he created the difference engine. Now, which is the device that you see off to the left. Now, what Charles Babbage designed is considered the first computer, called the Difference Engine 2. This computer was not built until his 200th birthday, but he designed it. Actually, it wasn't built. So we're going to watch a short clip about it. He also designed a cow catcher, a speedometer, and the thing is about Babbage that we want to know is that he was a mathematician and an inventor. Those two things that you're going to start realizing is that the basis of computers is tied into mathematics. Now, okay, so we're going to watch this short clip.
That's it for the first game. We'll be right back.
Sorry.
The commercial's on.
Commercials. Usually you're able to skip these, but that's the downside of using YouTube. You get caught in commercials.
The engine behind me is Babbage's Difference Engine number 2, designed by Charles Babbage, an English mathematician who is also known as the first computer pioneer. Babbage designed this machine between 1847 and 1849. Babbage, as we know, did not succeed in completing any of his own engines in their entirety, so there is no complete Babbage engine. This is the first physical realization of any of Babbage's complete designs in the metal. The engine itself weighs 5 tons. It consists of 8,000 parts made of bronze, cast iron, and steel, and it measures 11 foot long and 8 foot high. It's operated by cranking a handle. What it does is it calculates and tabulates the value of any 7th order polynomial, class of mathematical expressions, to 31 decimal places. It not only calculates that with unerring accuracy, it also prints an inked hard copy as a record of the results, and also produces what are called stereotype plates. That is, it impresses the results in soft material, plaster in this instance, so that you can make a printing plate automatically. Now, the purpose of all this was to eliminate the risk of human error in the calculation and production of printed mathematical tables. The machine is operated by cranking this handle. So you turn this handle, and each cycle of the engine, the machine produces one result. So you just keep cranking. You set the initial conditions up on the figure wheels, on the numbered wheels. You turn the handle. What happens when you turn the handle is it drives this cam stack. And if you like, this is the microprogram. This is the device that orchestrates all the internal motions of the machine to get it to form the repeated additions that are needed for the method of differences, which is the principle it is using. So you turn the handle, it turns these cam stacks. There are 28 separate cams, and that is what determines the internal timing and the orchestration of all the mechanical movements of the whole machine. So that's, if you like, the guts of the machine, the internal microprogram. And what the machine does is it adds a 31-digit number on one column, and it progresses through the machine, adding from column to column to column, and the tabular value, the result, ends up in the very last column, 31 digits. So you crank the handle. Each cycle of the engine, that's 4 turns of the handle, each cycle of the engine produces the next result on this column. So the end process, the end product of that whole process is a 31-digit number on this column. So we take the 31-digit result from the end of the machine at the end of the cycle, and it is automatically transferred to this apparatus, which is the output apparatus. It does 2 things. It prints on hard copy, in inked hard copy, a 31-digit result. That's a checking copy, so that you know actually what you've calculated. At the same time, it impresses results on soft material in these trays. So inside there are things called stereotype punches, which are number wheels, which are lowered into the tray. The tray then moves, it lowers again, and so the lines build up. Firstly, it's on display here at the Computer History Museum for 1 year. It's on loan from the owner of the machine, which is Nathan Mervold, who commissioned the machine. He paid for the machine to be built. And so it's here for a year, and then it goes into his private collection. What we will do with it is demonstrate it for people. We'll work on it. It's a research machine, so it will be adjusted and worked on. We'll get experience about how the thing operates. And also, part of the reason now that it is here and it does work, and we have for the first time a Babbage engine, The idea is to do some research and to say, was it a practical proposition? If Babbage had one, could they have successfully produced tables? Babbage was not an impractical dreamer. This machine works as he intended to work. But was the entire enterprise of using the infallibility of machinery to produce printed tables, was it realistic? Could it have been done? And for the first time in history, we were in a position to actually answer that question.
Okay. Now, in a way, a simplistic way of putting what this is, this, consider being the first computer, this Babbage engine, was a form of like a calculator. All right. It crunched numbers down to 31 decimal points. All right. Now, the next person we're going to look at is Ada Lovelace, who's considered the mother of programming from the 1840s. Now, she was a gifted mathematician as well, like Babbage. She also was a student of Babbage. She also helped work on the design for the difference engine. She is credited for being the first programmer. Ada programming language was named after her. So, and the thing is, which is really cool for all the young ladies out there, our first programmer in history, it was a woman, which is awesome. Cool. Catherine said she already knew a little bit about her. Awesome. Hopefully, this computer, the Babbage engine, is what you were referring to, Marissa. Okay. Moving on. Okay. The next thing we're going to be looking at is the data tabulation machine by Hiram Hollerith in 1890. All right. And as we move forward, and I want you to realize a lot of these original devices were created for like calculating purposes, to break down information. Okay. Moving forward. Okay, cool. Luke knew about this as well. All right, next. A Turing machine was created by Alan Turing, modern programming concepts, in 1936. Now, this was created to help explain the function of a CPU inside a computer. It can be adapted to stimulate the logic of any computer algorithm. So it's a processor. Now, Alan Turing is considered the father of artificial intelligence, as the Turing test, which, from what I've read about, is kind of cool, in my opinion. This test consists of a blind judge asking a series of questions to a human and a computer. If you can tell the computer from the human, the computer passes the test, the computer is said to be intelligent. So very different from what we consider now as an artificial intelligence. But we all have to start somewhere. And this is an example of that. The thing is, Turing helped develop hypothetical Turing machine due to the fact that to keep up with hardware evolved. So as hardware evolved, so did programming, and they go hand in hand with each other. Okay. Now, with regards to this Turing test, it's cool that the judge, if he can't decipher if it's a computer or a human, simplistically, it's said to be intelligent, which I think that's so cool, going back to what I was saying about how far we've come with artificial intelligence. Now that we have devices that chess players play computers and etc. And and we have these video game machines, and it's just so cool how logical decisions have changed with regards to what is artificial intelligence. Another cool fact about Alan Turing, he was instrumental in breaking the German secret code in World War II. And one of the things that's great, once again, is a lot of these people were highly involved in mathematics. All right. And that's where computing is the basis of it is in math. Thank you, Luke. All right, next, the first digital computer. Regards of John Vincent Astoff in 1937. This was the first non-mechanical computer. It didn't have a CPU, and it was not programmable. All right, but we're moving away from actual computers being more machine-based, and this having digital aspects to it. More moving towards what we would, as we evolve, consider with electronic aspect of computers. Now, Colossus, the first digital programmable computer, which was used during World War II. And we'll actually be watching a short clip about this in the future. Computer was developed by the British to help with code breaking during World War II. The computer was a massive series of racks and lights. It would help calculate numbers to help break down code for these. When I'm meaning code, like secret messages type code that the British were trying to intercept from the Germans, and etc. Okay, and one of the reasons Colossus was just had a colossal size to it. Now, electronic numerical integrator and calculator. The first mainframe computer was just huge. It occupied 20 by 40 foot room. Now think about that. It was 20 by 40 feet. It had 18,000 vacuum tubes and weighed 50 tons. I mean, that's just, wow. I mean, how big? And now we have iPhones. It's a computer. We have computers that we can wear. And going back, there's 50 tons. I mean, I think that's just mind-boggling. Now, it was developed by J. Presper Eric and John Mauchly at the University of Pennsylvania in 1946. Now, some people consider this to be the actual first true digital computer, even though the previous gentleman is considered to have that, because this one was programmable, right? Having a difference. And as you can see how we went from mechanical devices doing calculation, then to digital calculations, and now we have programmable, but it's still revolving around mathematics right now, okay? Compared to what we're doing now, sitting in a webinar with computers. Now, this is what is considered a vacuum tube. Vacuum tubes make computers possible. The size and cost make computers expensive and massive, though. This device controlled current through a sealed environment, okay? You used to use vacuum tubes for all types of things, but it made everything really expensive. It acts like a diode and was used as a switch. It was replaced by semiconductors and transistors. The creation of the transistor and semiconductors got rid of these and actually helped make advancements in micro technology, with making things smaller and being able to cut costs down. Before using the vacuum tube, they were bulky, they were big. If we go back to the previous image, you'll actually be able to see some. You can see the you can see them inside there. And when a tube would go bad, you would have to replace it. Okay? All right, now moving forward. All right, rear is Admiral Grace Hopper, the U.S. Navy's oldest active duty officer at the time of her retirement. She was a woman, very, very talented leader in computer programming, technology development, developer of the first compiler. It changes symbols we can read to symbols the computer can read for a computer programming. Very similar to what we'll be looking at a little bit with binary and bytes, with bits and bytes. Excuse me. We're looking at that as well. Very advanced, very talented, extremely intelligent woman who helped make some massive advancements. But just like many things, yes, Catherine, you know about binary. Yes, we're getting Luke. Yes, computers you can wear. We're getting to the point with Google Glass, for example. People are starting to develop watches that are basically computers. Okay? Yes, Marissa.
I'm homeschooled and I was at home and my mom wanted to see what the weather was. So we looked on we turned on the news, and before the weather forecaster person started talking, they talked about Google Glass. They're gonna each of them are gonna put on those Google Glass things, and you're gonna see like what it's like at the commercial breaks.
Yeah, it's getting crazy. I mean, that's a great example of what we're going to be at the point of wearing technology. Have you seen the smart watches?
Yes, I have. I saw a really funny commercial for that.
Okay, great. Thank you, Marissa, for sharing. All right. John Mark made a joke. He said, "What if Google Glass was 50 tons? That would just be strange." Yeah, and Luke brought up the point that Google Glass has not been completely fixed out. They're still making adjustments to it. And watches that are referred to are pretty much phones or iPods, and he's 100% correct. But the point I want you to realize is that if we still had vacuum tube technology, we wouldn't have what we have today. Everything would be still way too expensive and it would be bulky. All right, now continuing with Grace Hopper. She's, as we said, developer of the first compiler language, developer of UNIVAC 1 mainframe computer, COBOL programming language, and they still use COBOL today. This woman was extremely important, and this was done for the government. And a lot of the government aspect helped push for computers for other reasons. Okay. Hopper coined the terms computer bug and debugging. Other women who worked on computer and programming were often not named in photographs. because it was thought that they were cleaning ladies and not pros. Um, so it's really strange how the male stereotype has dominated even the time era back then. But so even see a woman in a photograph like this is really rare, and she was so far ahead of her time. Now, now, computers in the future may weigh no more than 1.5 tons. Now, it's popular science, circa 1950. I think that's hilarious. Like, we look back 64 years and 1.5 tons. He thought the smallest a computer would be is 2,500 pounds. And now we have computers down to tablets, to like a Google Chromebook. Um, but yeah, as Jean-Marc brings up, 1.5 tons was pretty light versus the Colossus, which was 50 tons. All right. Now we have, as we were talking about earlier, we have wearable computers that weigh ounces. So it's getting awesome, and it's only going to get smaller and faster and better. Okay, now moving into the microchip. Now, Jack Kilby and Robert Noyce developed the integrated circuit, or as we otherwise known as the computer chip, in 1958. And this is very important, like these milestones that we're looking at. The integrated circuit drove down the size and cost of computing. So we now can wear a computer for a very cheap cost, when the original computers cost millions of dollars, and as we stated, were the size of rooms. It's crazy that little extremely impactful inventions such as this drove down the cost. And as technology helped invent more technology and build on top of itself, we are able to have computers in our homes. And they're everywhere because of inventions like this, because of the discovery of semiconductors and transistors. Okay. Check up on the question board. Yeah, George said the MacBook Air. The MacBook Air is so light. And Drew said that we have an iPhone that doesn't even weigh a pound. Exactly. Contact Google Glass, maybe. Catherine brought up that there are companies, government research agencies that are working on not just glasses, but some form of internet-based, computer-based contacts. Okay. In the future. Now, next on our list, we're looking at is Douglas Engelbart developed the first mouse and graphical interface. Now, graphical interface, this is different. This is what we envision our computers and how we're able to interact with an actual picture instead of dealing with just code and very line-based code. We take it for granted that we can have images and we deal with things that are easy on the eyes, instead of just sitting here reading code and translating. Luke is loving writing binary right now. He's loving it. Drew said they have been developing very high-tech laser in the military. Yes. If you want to hear something funny about lasers, during World War II, Japan their scientists came up with two choices of what they thought were feasible weapons of mass destruction to help with their war effort, and they had two options. The first one was a death ray that they could shoot at people and it would like destroy them. The second one was a nuclear bomb. They didn't think a nuclear bomb was feasible, so they worked on a death ray. Then, ironically, the U.S. helped create the nuclear bomb and then beat them with it. So, I thought that was funny, but the laser made me think of it. Yes, Marissa.
Okay, so I have a question. So the iPhone, they keep coming out with new iPhones,
Yes.
and each one of them, I think, gets bigger and bigger. So they're computers basically.
Yes.
In the case of like back in the when they made that big giant 50-ton computer,
Yes.
that cost millions of dollars.
Yes.
And it kept getting smaller and smaller and cheaper. I'm wondering why now bigger is better, like the bigger the iPhone, the better?
Part of it is due to they're making the screen bigger. So it's making it more visually appealing for what you're looking at. It's kind of like having a small monitor versus having a big monitor for your computer.
Oh, we went to a Best Buy store and I saw this giant monitor. I was like, I think I like the smaller ones better because it was like
in all reality, you can actually weigh televisions. TVs and monitors are basically the same thing anymore, especially the newer ones. That you can just take like your LCD television and just make it your monitor for your computer. This summer, I was over at my friend's house. We hooked up a Raspberry Pi to his 70-inch television. It was pretty awesome. But, yeah.
He has a 70-inch television?
Yeah, it's in his living room.
What?
Yeah, I don't even know.
We have like a 54-inch, and I thought that was like really big.
Yeah, it's getting crazy. Technology making more technology, cheaper and bigger, and faster, and etc. But thank you, Marissa, calling some others. Yes, Luke. Go ahead, Luke.
That's actually kind of small. I would like to mention that iPhones are not basically computers because computers actually have the ability of downloading programs and letting you use a video flash player.
The thing is, the Apple software isn't real big on Flash.
I don't get it why.
I don't know the finer details. It's still a computer. It's just a different operating system. I can compare to a Microsoft-based operating system. It's something to do with Steve Jobs. All I've never looked into as much, that Steve Jobs had a personal thing against Flash. He just didn't like it.
I don't get why though.
Yeah.
That's it.
The thing is, there's a lot of different operating systems that, I mean, you have Linux. There's a variety of different Linux-based operating systems. You have your Apple OS, and then you have your Microsoft. But yeah, there's different things, but it's still a computer.
Yeah.
Okay, thanks, Luke. Let's go with Catherine. Yes, Catherine?
You know how they make iPads thinner?
Yes.
Every new version? I thought it'd be cool if they made one that was super thin that you could fold it up and stick it in your pocket.
That'd be kind of cool.
Yeah.
That'd be real cool, actually. Yeah, you work on that, all right? And you give me, and I'll prototype it for you. I'll test it out.
Okay.
Thanks, Catherine. Let's go with Jean-Marc. Jean-Marc, you're unmuted. Okay. All right. Go ahead.
Okay. Actually, I've had a few things to say.
Okay. I had a list of people with their hand raised, so I was just working my way through.
I've never really gotten to say it. One thing is a little fun fact: Einstein helped create the nuclear bomb, but he was a pacifist and he didn't want to have a war.
Yes, he actually was part of when he was in Germany. He was part of this scientists coalition against like weapon development.
And another thing,
Yeah.
I have another little note about the iPhones.
Yes.
I have a 3G and a 5C. I've noticed that as the iPhones get longer
Yes.
and a bit bigger, they get lighter. So, like, I'm pretty sure eventually they're going to have, like, the iForce field that you can't even touch, but it's there.
That's cool. Huh.
Yeah, that would be awesome.
That would be awesome.
And then if you didn't see my little Google Ask comments, that's basically true if you think about it in a sense.
Yeah. Well, thank you for sharing. Appreciate it.
Okay.
All right. Okay. Now, back to this. This mouse is not the original mouse, but it just represents one of the earlier mice of the past. In all reality, the first mouse would have been much bigger than this. Okay. Now, we're going to start looking a little bit at the makings of what we call the internet. The ARPANET, the internet is demonstrated in 1969. ARPANET was the forerunner of the internet. It was not created. It was supposed to help with if something happened with a nuclear blast. It's created because at the time computers were few in numbers and they were so big and expensive, as we keep talking about. The ARPA, which is now the DARPA, wanted to share resources similar to what we would consider cloud computing today, and all users sharing the huge, powerful server. So it was developed very similar to what we use it for now, but it was for sharing of information and to share data across areas, just because it was so expensive to have computers. So we can interconnect these. And you can actually make out some of the locations. There's quite a few colleges on here. MIT, as well as Rutgers, NYU, Harvard, the Pentagon's on here. There's certain states where it's located and they are interconnected. Okay. Now, moving forward. Now, RAM chips, a dynamic random access memory chip. Okay. Now this, where we're looking at starting to move in the direction where we can store information. This becomes the memory chips of computers because of its simplicity. This simplicity is a single transistor and capacitor. Helps computers become more powerful and cheaper. The data on this memory is lost and the power is turned off, though. The first memory chips, they would only be useful for what you had on right now, but if you turned things off, you lost it. So it had to have power. Kind of like alarm clocks that when they lose their power, you have to like reset them. I mean, it's a way of looking at it. Okay. Goodbye, Elizabeth. Holograms are cool, Luke. Stanford, yes, Catherine. Cool reference. Phone touches you instead with the iPhone 26. Now, on your Raspberry Pi, you're going to be using an SD card for memory. The Raspberry Pi is static and the memory is not lost when the power is turned off. So, which is different from this DRAM chips that were created by Intel in 1970. But you can see the progression coming. Now, personal computers entered the market and became very popular. These included TSR 80s, Altair, Commodores. Now, the thing that was great about this is now that we have people being able to have computers at home. TSR 80s, or affectionately called the Trash 80, was sold by Radio Shack and was hugely popular the first year of its release. So now you start having computers where people actually have access to them, which we didn't see this before, because up until then, they cost too much, they're too big. Now, as technology kept being more and more advanced, we start to have memory. We can actually, we're not using vacuum tubes anymore. We have transistors. You see the size of things dropping. We're actually getting more and more digitally based computers, and this evolution of the computer continues, and it's continuing today. Now, the Apple Computer 2, created by Jobs and Wozniak in 1977, to the Apple fans out there. Now, so we have this computer as well. Apple getting on the scene. And I remember using these old school Macintoshes in the 80s when I was in school. Now, all right. So that's a little bit about personal computers. And now we have VisCalc spreadsheets and WordStar word processing bring important functionality to personal computers. So because of spreadsheets, because of word processing, which we use Excel as well as Excel and Microsoft Word, businesses now want to start using it. Because businesses are buying such large bulk of them to use for building spreadsheets and creating documents, it helped the market in the late 70s to make computers cheaper, because people are investing money and time into them now because they're actually wanting that. Yep. So Alex said that his family has a TRS-80 Model 1. That is awesome. Yes, and they do look old. Luke, yeah, we got... Yes, Luke brought up the point. The Pentagon is highly classified in the United States information, is also filled with our phone records. Yes. Now, well, as I was saying, you are able to enjoy your computers gains because of business software. Businesses, as I said, bought lots of computers, which the price of these has dropped because they make computers accessible to people at home. Now, that's the great thing about personal computers. Now, businesses start using them because they're using them. People are getting exposed to them. They think, oh, this is so cool, because businesses buy so many of them. Companies are investing more and more money into the development. That development helps drop the cost of them because they're mass producing them now. Now, this is the IBM PC from 1981. IBM PC comes to the market using Microsoft DOS Disk Operating System. So when you hear the word DOS, that stands for Disk Operating System. It is a huge success and established Microsoft as the operating system of choice. This deal that Microsoft made with IBM put Microsoft on the map. And someone was telling me there was a story where Bill Gates had to make the choice of selling per unit or selling the whole operating system. Like, I forget but it was a major choice, and ended up he made the right one and made a ton of money off of it, and it's just launched Microsoft into a big time player, which they are now. All right, the next computer we're looking at is a Macintosh computer from 1984. And I actually remember using one of these. This is the first computer with a graphical interface. The Macs of today are direct descendants of this computer. So to those who have Macs, this is its grandfather. Hi, the bubble. All right, that was my computer voice. All right. By the mid 80s, personal computers are reaching mainframe performance, meaning that mainframes were still being used because they were faster. They were huge, but they were faster than a personal computer. But as technology, as I keep trying to pound that home, technology helped its advancements made personal computers more and more accessible and made them just as awesome with performance compared to mainframe. Such as a compact 386 is the first to introduce 32-bit architecture, which gives mainframes performance. So that's off here to the left, and then you have this giant IBM mainframe. Okay. Now, with the advancement of what we consider the modern day internet, Tim Berners-Lee, he creates, is a CERN researcher and develops HTML, which so many websites are made off of. And HTML is hypertext markup language, which fosters the creation of the World Wide Web, where we got away from the ARPANET. Is taken down, which was used primarily by colleges and governments to share, or government in other countries did it, such as France and Britain. Shared these different types of nets are taken down, then we interconnect the internet using the World Wide Web, the WWW. And the modern internet, what we know today, is considered functional, which is really cool. So the next thing we're going to look at is a short video on the history of computers. So we're going to take a look at that. Let me switch over to my other screen. And this is from the History Channel.
This content is currently unavailable. This content is currently unavailable.
Let me refresh. Let me do it this way. Let me pull out the link. Well, looks like they're having some. All right, we're just going to move forward. There's obviously the video that I was looking for, the link has changed. Here we go. Click on video. What? This is not. All right. We'll just go on. What I'm going to let you look at, and I'm going to give you a minute or two to do this, is this link here, and all I'm showing you is that there's this really cool on the History Channel, has just a whole history about the involvement of and advancement of computers. And it looks at Apple, looks at Bill Gates, it looks at our U.S. government using them, and just how they have changed and evolved over the years, which is really cool. Man, there's some really awesome pictures, NASA, etc. People just using the computers, but showing it as how it has evolved. Okay. Okay. So let's just move ahead. Also, we're running out of time as well. Okay. Now, so by the 90s, people were starting to develop the internet for search engines of what we even know today. I mean, and using it for shopping by the mid 90s, which was a major change, from being a sharing information for military and technological purposes to, hey, I'm going to buy something on eBay. All right. So massive changes. And then Napster was born. I remember when this happened. I had Napster on my computer, and this changed a lot of things because it really was the start of open source sharing. I had Napster in high school, and people were just sharing music. You would upload your music, share it with other people. People would share their music with you, and it was crazy. And then all of a sudden it became illegal, and it changed the way like the music industry worked, videos, etc. And a lot of laws started changing about pirating, as well as legal basis of what was considered to be purchased or sharing, etc. But you can tie back the open source community back to this kind of moment. Then in 2001, Apple Computer introduces the iPod. And this is Apple starts moving from a computer company focused solely to a consumer technology company. iPod becomes a huge hit and sets the standard for digital music. All right. So as technology gets smaller and some of these advancements, it really changed the game on how we do things. Microsoft specializes in gaming computer, Xbox, and joined Sony PlayStation 2001. So we have these things that are computers, but not what they used to be, like going back to even 1840s where they were just calculators. Computers manufactured to solely play games and use cartridges and discs. While very popular because of easy access, the kids are no longer needed to program the games they want to play, which starts changing things. Where we start having more graphical interface. You're not developing your own games to play compared to computers in the 80s. You actually just pop a disc in or download something as you do now, and you play a game. And this really changed the way we do things. And that's why we're moving into the Raspberry Pi, and it'll make more sense momentarily. Actually, this year, Facebook is celebrating its 10th anniversary, founded by Mark Zuckerberg, and this was groundbreaking. I remember when I first got my Facebook account. it really changed networking. This social networking aspect. Now, so many other networks have been developed since then, from fun ones like this to professional. I mean, even companies change the way they market now due to the advancement of this technology. In 2006, Twitter soon followed, thus beginning the age of social media. We're not active using the internet when we aren't playing games or Googling ourselves. So the internet has really changed for what it was used for. And even today, it's still evolving. In 2006, we see the start of Google Docs is released, and this is like the start of cloud computing, and where we're storing things out in the cloud and digitally. Okay. In 2007, Apple releases the iPhone, which now we have so many different types of smartphones, Android and Google having their own. And then one thing I want you to realize is that less than 40 years of computers went from the size of a room to the size of your phone. And I just think that's wild. We go from 40 years, 50 years, the colossal mainframe computer to handheld. And that is all this technology advancing itself and just making it smaller and smaller and smaller. Okay. And it's not just a computer. We have a camera built in as well. I mean, that's a whole nother area you can think about. And it's fun. Okay. 2010, iPad is released, which doesn't even seem like it was that long ago. We have your iPads released, and we have tons of tablets now. I mean, Amazon Kindle, the Samsung tablets, and these are smaller and faster, lighter, without smartphones. Screen limitation tablets have replaced many laptops, which had replaced desktops. So it goes creative destruction. We go from mainframes to desktops to tablets, to laptops, to tablets, and it's definitely changing. The thing is, all these devices are computers. Excuse me. And they might have changed what they were originally used for, but they're still evolving, still changing. Okay. Now, real quick, I'm going to scroll through this. History of computing in a nutshell. Information, you have data and instructions. Management, storage, transfer, and process. You have input and output. And I'm moving a little bit faster, but bits and bytes. Bytes consist of zeros and ones, basically looking at it as false, true, off, on, no, yes. And this is a binary code when we hear that. Now, when you have a bunch of bits, I keep saying it wrong. It's called a byte. When we have bytes, we can start grouping these. And this is where our foundation of coding has come from. And everything starts representing other things. With CPUs, we have central processing unit, but I'm going to get to the Raspberry Pi, and then we'll wrap up class. Raspberry Pi is released in 2012. We talked about technology getting smaller. The main reason why we were able to use a Raspberry Pi, a microcomputer, is the fact that this center chip is it's an ARM chip, which is used in smartphones. that technology, because the processing capability has gotten that small, that we're able to use things like this, a $35, $40 computer. Now, the reason it was created is that British educators realized fewer kids were going into programming due to how kids were interacting with computers. And I brought this up earlier. The fact that we have graphical interfaces, as well as we have games where you just pop it in and we interact with it, kids aren't, you don't have to discover programming as much and use it. It's way computers are designed for now is that they're almost dummy proof. You turn it on, you use it for a purpose. You don't have to make any discoveries. Where computers usually you had to know some type of basics, and more the basics you realize you can develop and program. And because of smartphone chips, as I said, have gotten more powerful and cheaper, we are able to have these computers. Okay, ladies and gentlemen, hopefully you're excited to be moving in the Raspberry Pi direction. Have a wonderful night, everyone. And happy binary code to you. All right. Take care, everyone. And as always, thank you for being part of Young Engineers today. Have a good night.